All right, let's see two examples on how to apply exponential function on business problems. We discussed this one on exponential function, but let's see some examples. You know that the formulas for compounded, interest and continuously. So when you do your assignment or quizzes, the formula is available. So you have to use those formulas in order to solve such business application problems. Let's see the first example. A person wishes to have, this one, 21,400 cash for a new car 7 years from now. So these are important. How much should be placed in an account now if the account pays 6.1% annual interest rate and compounded weekly? These are very important. So from this problem, you can see that you have to identify the givens. So a person wishes to have 21,400 tells you that the future value is $21,400 and the time is 7 years, and the other given is here. The rate is given, it is 6.1%. You have to convert into decimal, so you have to divide it by 100, so this becomes 0.061. And compounded weekly, this one is weekly means, so how many weeks do we have in a year, which is 52. That is compounded weekly. So the payment is generally per week. Now we know that the formula, future value, the initial deposit or the current present value, 1 plus the R is the rate over n times t. So we have to substitute all the given values into this formula and evaluate the unknown. The unknown in this case is the principal, so the P is unknown. Now let's substitute. This one, A is 21,400. So P is, that is our goal. 1 plus R is 0.061 divided by 52. And on top, 52 times 7. Now this is a form of exponential function. So in order to solve for P, I have to divide the right side, on the left side. So P becomes 21,400. To isolate P, I have to divide it everything. 1 plus 0.061 over 52. And remember, you have to use your calculator. 52 times 7 is 52 times 7. You get 364. Now make sure to use this one. Use numbers carefully and plug in into your calculator. So 21,400 on top divided by, please open parentheses and put the other numbers. 1 plus 0.061 divided by 52, close the parentheses, use the exponent and multiply 364 and close the parentheses, and you will get the result, which is, my result is 13,966. It says nearest dollar, so that is the value. You don't need to worry about the decimals, as long as the decimal in this case is 2-1. So the nearest dollar becomes 30,966. So such problem needs some kind of attention on how to plug in onto your calculator and how to use your parentheses in your calculator carefully. This one is different from the other one. This one is compounded continuously, so make sure to use the right formula for this one. So this one is, the initial investment is 1,000 and grows to 1,800, and the rate is this one. So how long does it take for you? So the formula is A is equal to the present value ERT. Remember, E is the base of natural logarithm. A is, now from the given, A is, your goal is to get 1,800 and invested initially 1,000, and the rate is 2.25%. So this is 0.0225, right? So once you identify the values, you have to plug in into the formula. Now I can plug in 1,800, P is 1,000, E is a non-constant, but you can use your calculator. This one is 0.0225 times t. So time is unknown. Now, if you look at this one, it's an exponential function, so you have to convert into logarithm. But first, let us simplify this one by dividing by 1,000. So this cancel this one. When you cancel on the left side, it becomes 1.8 is equal to e to 0.0225 t. So the log form of this one is 0.0225 t is natural logarithm of 1.8. So in order to find t, you have to divide this one by 0.0225 divided by 0.0225. So the left side cancelled. So our objective is to find t. We're successful now. ln of 1.8 divided by 0.0225. So I have to go to my calculator and just click ln 1.8 divided by 0.0225. So the result becomes 26.12 years. This is rounded to, let's say this is 2 decimal places. Round to 2 decimal places. Please follow the instruction on your assignment. Sometimes it says round to 2 decimal, sometimes it asks you without any decimal, and so on and so forth.